Hello developers, let's start developing. My name is Veko and today we'll be solving the fifth part, the fifth puzzle of the 2021 Advent of Code. Let's see what it is. Hydrothermal Venture. Okay, this is at least title-wise better than the giant squid. Hydrothermal vents on the onshore floor constantly produce large opaque clouds, so it would be best to avoid them if possible. They tend to form in lines. Helpfully produces a list of nearby lines of vent your puzzle input for you to review. Okay, so one thing, let's take a look at the input. So the input is, yeah, we're definitely gonna use the regex to parse this. So let's start with that. Oh, we're gonna paste this here and let's see if we can parse it somehow. So we have multiple numbers, then a comma, then multiple numbers, then a space, a dash, and then another space, and again the numbers and the comma, and then we have end of string. Is everything mapped? Fortunately no negative numbers that I can see, so yeah, this will be something like that. At least the parsing will be easy. Let's add some parentheses so we will be able to extract them nicely. Yay, everything is nicely colored. Okay, back to the task. For example, each line of vents is given as a line segment in the format. So this will cover those polygons, this will cover them. Only consider horizontal and vertical lines. So either the x coordinate will be the same or the y coordinate will be the same. So that means that we won't have a situation like 0, 0 moves to 2, 2. So yeah, let's have the following diagram. In the diagram, top corner is 0, 0, bottom right corner is 9, 9. So the coordinate system is a bit like this. So this is the x-axis and this is the y-axis, actually like this. Something. This is the x-axis, this is the y-axis. So the y-axis is negative, which is kind of usual in computer programming because your 0, 0 point is usually here and your maximum point is somewhere around here. So, okay. Each position has the number of lines which cover that point or dot if it's 0. The top left pair of ones, for example, comes for top left pair of ones. Yeah, this one. Overlapping lines. Okay. The numbers of points where at least 2 lines overlap. Well, the naive or trivial idea is basically to construct the diagram. And since we have something in the neighborhood of 1,000 points, 1,000 by 1,000, that's a million, and that's not great, not terrible, I would say. So this is day 05.ts. We will need to put it, this is the solution 5. The day index will be 5. Let's create the input file day 05.txt and let's plug in this. Okay, we will just need to import that solution and set it as the active one. Yeah, this is a bit of a manual task, but We only need to do it 20 times. Let's see if this will give me something. Yeah, it will just need to tell me that it's running code for day 5 too, so that I know that I handled the infrastructure okay. Yeah, running day for day 5 and the result is 0. It's not 0, but we're actually not reading anything. So we're gonna read the input and then I'm gonna shamelessly copy it from one of the previous days. Yeah, we have something like this and then we're returning something using a regex. Yeah, that is a pattern that we're gonna reuse, only our regex is a different one this time. And that's the good thing about regexes, that once you have something with a pattern that uses a regex, well, you can just reuse it. And if we have a match, basically return the, and we will need to have something like a, yes, let's create an interface for this, and this will have an x that is a number, and of course it will have a y that is a number, and we can have, since this is a hydrothermal vent, let's just call this a vent. This will have a from, that's a point, and a to, that's a point. And I need to call this an interface and not an interface. So that means that we have an array of vents as our input, 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 show input, and test as well. So here we will need to return, well, we will need to return an object that has a from and has a to. And again, I will invert this because I don't like too deep ifs. If we are able to have everything one line closer to the left margin, it's that much better. So if we don't match something, that means that we messed up somewhere. So in that case, we're just gonna do this, and of course I'm gonna add the tens here, just in case, because JavaScript is usually weird. And you can see that Copilot already picked that up, that I actually want to do that. So first of all, let's do the debug run and see if this, oh, we need to return not the input, we need to return the result. Yeah, let's run this in debug mode so that we can just see what is happening. We can see that we are getting the input correctly. Of course, if we don't get the input correctly, then we're not going to get the result correctly. So the first one is 09259 x0y9, and that's what we wanted to. The last one is 5582, and we have 2, 4, 6, 8, 10 of these. Okay, but this one sounds a bit different. 55282. For now, only consider horizontal and vertical lines. So yeah, we're gonna have to do the diagonals as well. So this means that what we're actually doing is that we are only considering those lines. Let's see, we have 1, 2, 3, 4 lines here, or 5, 6, 7. So out of these 10 lines, this one is okay, this one we're removing, this one is okay, this one is okay, 7, 7, this one is not okay, this one is okay, this one is okay, this one is not okay, and not okay. So we only have 6 lines. Let's see if those 6 lines are represented. 0, 9 to 5, 9. That's the one at the bottom. Let's have it like this, and then we have 9, 4, 2, 3, 4. That's 9, 4. Yeah, this, I guess it's this thing. 1, 0, 1, 2, 3. Yeah, it's this. 2, 2, 2, 1. Yep. So we have 1, 2, 3, 1, 2, 3, 4, 5, 6 lines. Yep, we only need to run those 6 lines. So the first part will be actually to filter this. We need to basically have the horizontal or the vertical lines, so I will just call them lines, and that is not it's not input map, that's actually input filter. For each vent, well, I want to return if, not this, definitely not this, but I want to return if vent dot from dot x equals to vent dot to dot x, or that means that is a horizontal line if the x is constant, or that went from y equals to went to y, and that will give me the lines. So let's say console.log lines. Let's see what we are left with. If this is working as expected, we should get 6 lines, and we are getting 1, 2, 3, 6 lines, and those are the lines that we 1, 2, 3. Yep, those are the 6 lines that we actually want. We'll have to take care of the rest in part 2. One of the things that is quite important in Advent of Code is not to make assumptions about what the second part will be. I'm quite sure that the lines that are we just excluded from the input will become relevant, but let's cross that bridge when we come to it. So right now we have the lines, and let's make the diagram. How high will the diagram be? Well, let's get the maximum values. The max x lines dot map each line to the map dot max out of line dot from dot x, line dot to dot x. Actually, let's do this flat. For each line, well, generate me this array. What's the problem of type? Well, this is an array of numbers. And what is actually flat? Oh, this is the generic flat. Extends number equals 1. Who actually did this? The depth? Yeah, it should be 1. Do I need to explicitly specify it? And what does it say now? 0 or 1 arguments. flat doesn't work like this. I need map and then flat. Okay. And this will give me a list of all the x coordinates. These are the x's, and of course we can have the y's. And x max is of course this, y max is this. Let's see what those maximum values are. If we are correct, it should be 9 for the y's and 9 for the x's. Yep, 9, 9. Again, this is not really the most elegant way to do this, but it's relatively functional and we're just passing through the whole array twice. Once for x's, one for y's. We can have a better code, but don't really care. This might be different if we had several billions of events to process, but for up to 1,000 it will be lightning fast. So we have that, and let's create that. Let's create a matrix that will have actually 10 rows. Let's have it x max here. Actually, how many rows we will have. If x is from 0 to 9, we will have a row for each x. Yes, this needs to be x and this needs to be y. So we will create an array with 10 0 from 9 rows, 10 0 from 9 rows, fill it with zeros and then map it. This field here is completely necessary even if we're just mapping it later, because the new array constructor actually creates just the array, doesn't create the elements. So we need the fill to actually create the elements. So after this is done, we will have an array of basically a matrix x max plus 1, y max plus 1 that is filled with zeros. If you don't believe me, let's log the grid. It will just give us a bunch of zeros that we're gonna assume are enough zeros. It's 10 by 10, I guess. Yeah, 10 rows of 10 zeros each. And now we're gonna run a for loop across the lines. And since we know that either the x's are equal or the y's are equal, I can do something like this. The index of the row will be basically we need to sort the lines somehow. We want to go from the smaller to the larger number. So let's get our lines. So this one will be okay, this one won't, this one won't, this one will be okay. Because you can see that these lines are actually, this line is totally identical with this line. I will hit the tree eventually. So these two lines are identical. So we need to go from the minimum x. Let's have that. From x is actually the minimum of the from and the to, and then we have 2x, that's the max, and then we have, yeah, I guess that Copilot can definitely get this and this. So we have from x, from y, so the row index will go to from x up to and including 2x, and it will just increase. We will have the same loop inside it, and we will just call this column index, and that goes from y to 2y and increases by 1. It's quite possible that I managed to flip the grid around, but let's see if I do it. Note that at least one of these force are nonsense force. They will go from 0 to 0 or from 9 to 9. Here the y will go from 9 to 9. Here the x will go from 7 to 7. But okay, it will execute once, and once is basically all I need. So we will say that grid for row index, column index is increased by 1. And we will just, after this triple for loop gets executed, it's not triple because at least one of the for loops is degenerate. So a lot of people will just see, oh, you have 3 for loops, that's scary. Not really. I still know exactly how many times this will execute. So let's see what we have. 0, 0, 0, 0, 2. I definitely managed to flip it, because the first row is actually 0, 0, 0, 0, 2 here. And then we have the next one is 1, 2. Yep, 1, 2. 1, 1, 1, 2. 1, 1, 1, 2. Yep. So that means that these are the other way around. The result will still be just the same, but I kinda like it when I manage to get the exact thing that is required, but is specified by the task, because then I can kinda reason about it. So zeros and one with a single one at the end, and when you have 2, 2, 2, 1, 1, 1. Yeah, so right now this is completely trivial. Map each row to basically to just a second, let's do this a bit better. Let's do the display better. We can map each line to a line that joins on an empty space, and then we can just replace all the values that are 0. Yeah, now we're working with strings with a dot. And for each line in this array of strings, well, just log it. Let's see what we get. We are getting that we are using possibly an incorrect version of TypeScript, because it detected that the replacement L method is not available. I'm not sure from which version that is available, but I think this will work just as well. No, it doesn't, because it just replaced the first 0. Okay, this replace is stupid, but you can see what we are driving at. We got something that looks a lot more like the diagram we wanted to do. Anyway, we can map the grid, so each row is mapped to the count of cells which are 2 or larger. I have no idea if this is okay. How the fuck did it know this? Sorry for swearing, but this is terribly specific. And I think I might be actually using some other guy's code who already solved this thing. Because that is just like I wanted to do. So we're filtering all the cells that are bigger than 1, that's 2 and above, and we're getting the length. So we are mapping the rows into a number basically. So this row will map to 0, 0, 0, 0. This row will map to 2, 0, 0, 0, 0, 3. And then I'm saying, well, sum them up. JavaScript does not have a sum function, but this reduce does exactly the same. So this is terribly specific, but I intended to do exactly that. And this code can only exist from something like 10-15 hours ago. Okay. The result is 5. That's what we needed, so let's try with 500 lines. And this might be a bit slower. Oh, it's not, because we are doing about 1,000,000 cells, 1000 by 1000, but still it says 65, 64. Let's see if that is correct. That's the right answer. 1 gold star closer. Let's see what the second part is. Doesn't give you the full picture, you also need to consider diagonal lines. Well, that's okay. That's cool. I was worried that we will need to cover also lines that go across weird angles. So diagonal lines are lines whose equation is something y equals x or y equals minus x. It won't be that problematic. So diagonal lines are always at exactly 45 degrees to something. Okay. So let's go back to all the lines. Actually, I will paste them again. These are the 10 lines. And let's see. This one, well, we need to run a diagonal check. That's what I'm worried about. This one is horizontal or vertical, horizontal or vertical, horizontal or vertical. And this one as well. So this line 8008, if we have 2 points, we can determine the slope basically on the difference. So the first difference, the difference between the numbers needs to be the same. So between the x and the y coordinates. So 8 minus 0 is 8. 0 minus 8 is minus 8. So we have 8 and minus 8 here. So this is a diagonal line. That's okay. And here we have 6 minus 2 and 4 minus 0. This is a diagonal line. Of course, this is a diagonal line. And here we have 5 minus 8 is minus 3. and 5 minus 2 is plus 3, so this is a diagonal line as well. You know what? That's the first thing I will do here. In the second part, let's take this. We might copy over lots of code from the part 1 to make a part 2. Let's just get the ones that are not this. So this is different, and this is different, and these are non-grid or diagonals, actually non-grid. And let's say I think this will be able to guess, oh, this is definitely much more than I had in mind, but I will definitely need math.abs of non-grid. Yeah, I will kinda need the loop as well. Let's have a simple loop. For each line of non-grid, xdiff is line.from.x minus line.to.x, and of course ydiff is the line from the other part of the coordinates. If xdiff equals, if this doesn't equal this, so I'm gonna play around with the input to see whether we have lines that we can actually, we will need to actually throw away. Otherwise, if everything is either horizontal, vertical or diagonal, we're golden. So let's see. On the small input, since everything is horizontal, vertical or diagonal, it should just say 0 and everybody is okay. Let's see what happens with the 500 line input, because I'm not gonna go over it with a fine-toothed comb to see if everything matches. I will use some code in order to detect it. Well, yeah, everything is horizontal, vertical or diagonal. Great. So that means that this is actually diagonals. So this is a dangerous thing to do if you are working with unknown input. But we're not working with unknown input here. We're working with a terribly known input. We don't have to solve the general problem. We don't have to solve world hunger. We just have to solve the task that's in front of us, and the task in front of us guarantees that all the lines will either be horizontal, vertical, or diagonal. So I can more or less reuse most of this up to here. So these are actually grids. Let's so call them. Or we already have a variable called grid. These are grid lines, horizontal or vertical. So this actually splits our input into two distinct sets, two distinct and complementary sets, because everything is either a grid line or a diagonal. I will move this above that, and the calculation of x max and y max are actually should be done on the input, not on the grid lines only. because the diagonals have also values. So right now we are sure that the x max, y max and the grid actually covers our whole set of values. And then for the grid lines we use this piece of code to completely cover them, but notice that we counted on that one of these force will be a degenerate for, because we are kinda changing two values and setting each. If we were attempted to run this code for a diagonal, what we would do, we would fill out a square. Because for this, for example, we will fill out every number that's between 0, 0 and 8, 8. So we would fill 1, 1, which we want, but we will also fill 7, 2, that we don't want. So while this loop will cover only 3 values, 1, 4, 2, 4, 3, 4, and that's it, this loop will cover 64 values, and we wanted to cover exactly 9 values, 0, 0, 1, 1, up to 8, 8. So we kind of need have a different for loop for the diagonals. Of course, I feel it's quite possible to have a single for loop that will go through all the lines, but we don't really want to do that. So for the diagonals, we will have two cases here. We will have the ones that are going this way and the ones that are going this way. Let's think about them. So actually, from x and to x, that part is okay. So we definitely know that none of these four values are okay. These two values are not the same, and these two values are not the same. So we want to run them with a single loop. We will run an index from, and we know that the difference is the same. We just need to find the direction. Actually, what we will do, we have from x and from y. Let's see. This is how many items we will need to run, plus 1, because we're counting the points. So from 0, 0, 8, 8, we will get that we need to have 9 iterations. And x direction, do we need to increase the x and do we need to decrease the x? So if from is less than 2, then we need to increase the x, otherwise we need to decrease it. And the same thing we will need to do for the y direction. So right now we can just say that this will be a single index, and it can start from 0 and it can go up to count, increasing, including count. Does it include count? No, it doesn't, because count will be 9 from 0, 0, 8, 8, and we want to run 0 through 8. So this is a proper for loop, and yeah, somebody already did this code because this is exactly what we wanted to do. So basically we will calculate x, and that is as many points from the from in the direction of x direction, and similarly the y is the same thing with the y direction, and we're just adding it to the grid. After we're done adding it, this is totally and completely the same. Let's run it once more on the small input. It says 12 and it was supposed to say 12. Actually, I wouldn't mind actually drawing this. So let's do that. But this time we're gonna do a proper thing, and I actually think I have a print matrix method that will take a grid and it will take in a processor that will need to that shows how to draw a cell. So for each cell, if the cell is 0, then we just output a dot, otherwise we output the cell. Yeah, that is just a helper method, because when you're doing advent of code, printing matrices comes in handy, especially if you can print them however you want to. And I printed it in an ugly way because somebody didn't ask it to print dots. It says print zeros, and of course it printed zeros. So 1 1 1, and then we have the star-shaped thing in the center. Yeah, that part looks about the same. So I think that we have our solution ready to go. Let's use the huge input with 500 vents, and let's start it and see whether it lasts for a millisecond or a bit longer. 115 milliseconds for part 1, 126 milliseconds for part 2, and it says the answer is this much. Let's see. Fourth gold star. We completed day 5. Let's return to the advent calendar. Well, this is starting to get to show something. So we're still far away from the keys. We have a lot more days to go, but we're 1/5 there, and we already have 10 stars. That's always a nice thing. Let's try to run this in the proper console. I know that I have this somewhere to see whether the speed was a fluke or it is just that slow. No, it's just that slow. Not git push. I wanted to do this. Yeah, it varies a bit, but it's about 1/10 of a second. The input processing is very fast, but we have 1/10 of a second. And I think that most of the time is actually spent managing the huge array, because that array has about let's actually see that how many items that array has. For the real case, and that means that we have 980, nope, 981 times 900, 991 times 990. That is about 1,000,000 cells. That's not too much. That's like 4 megabytes of memory. but still it is a bit too much. I think that we could make an analytic solution of this. Basically, just from looking at the numbers, we can determine whether they are intersecting somewhere. And if they are, we can just find the intersect. But for now, I think this is more than good enough. My total goal, overall goal, is always to have my complete code run in under a minute. So as long as I hit that target, I'm quite okay. Sometimes it's obvious that something can be uh, optimized or changed or made into a better solution. One such example is the task from yesterday. My solution is awful, but is relatively fast. So I will try to ignore that for now until and unless I need to optimize it somewhat. You can see that we have a task here, basically task 22 I think, or 23, that is running much slower than the other tasks. Oh. And if I remember correctly, this is from last year. If I remember correctly, it takes up like 60% of the total running time. But you can see that the total running time is 40 seconds, which in my opinion is good enough. And this part, actually, the running time of task 23 is 49% of the overall running task. So it kind of doesn't make any sense optimizing something that will turn out to be a percent of a percent. So that's why I'm not happy that this is so slow. But I'm quite okay with this running time. It can be heavily optimized. Whether I want it to be, not really at the moment. So that's about it, and see you tomorrow.